This is our second class on Coulomb's law. Today we are going to discuss some numerical problems on Coulomb's law, and then we'll discuss the Coulomb's law in vector form. Okay, so basically it is the second class. So we already know the formula, the force between two charges. Okay, in vacuum, that is equal to what? 1 by 4 by epsilon naught Q1 Q2 by R square only. Okay, so from that only we have to do the numericals. So let us first hit one numerical. Okay, well, to solve this problem, a particle charge Q and what maximum charge that can be transferred from it to another particle. So the electrostatic force between them is maximum. So I'm going to give you 3 minutes. Okay. So you please give an attempt first.
Hello.
Okay, welcome.
Good evening, sir.
Good evening. Yeah, Moyak is correct. Okay. Well, say this is the charge particle. Okay, it has charge Q, and this is another particle which has no charge. Okay, initially. But what I do here, from that capital Q, say small q is transferred, okay? So it means what? It means it will have q minus q charge, okay? And the separation is say r. So what will be the force between them? So force between them will be what? F equal to uh, F is equal to Coulomb's constant. Okay, I'm writing with a small k. Q1 is nothing but q minus q. Q2 is nothing but small q divided by r square. R is same only. The separation between them is same. But now you can see here, if we keep on increasing q, it means if we keep on changing small q, so a capital F also will be changed. We can say that capital F is differentiable, okay, with respect to small q. If we want to break it, it will be like this, okay? It will be q into q minus q square. So as we need to maximize the force, no? So it means dF upon dq. And differentiation of F with respect to small q will be 0. Yeah, it will be dq of minus dq of q square. So as the force is maximum, so maximum or minimum, na? So differentiation of maximum quantity or minimum quantity, which will be 0 only. If F equal to F max, so differentiation will be 0. So it means we can write k by r square. So here it will be 1 only, na? dq by dq. So it will remain q only. And here it will be 2q. Because it is q square, na? So 2 will come. So it is equal to 0. So from that, you see this part is not 0, so this will be 0 only. Q minus 2 q equal to 0, it means q equal to q by 2. 50% charge should be transferred from one to other. You see, without that one doing that calculation now for differentiation, then also you can find the answer actually with some logical that one reasoning. Say it is having some 10 Coulomb. So if I divide the 10 Coulomb into two parts, say one is 9, another is 1. So 9 into 1 will be what? 9 only. Because it will be multiplied only here. So if I divide it 8 into 2, so it will be 16. As you see, as this part is going on increasing, their product is also going on increasing, means force will go on increasing. So it will be maximum at 5 into 5, okay, 25. If you increase more than 5, na, say this will be 4, this will be 6, so it will be again 24. It means it will reduce. So for some examples also you can find the answer that the force will be maximum when the charge is when the 50% charge is splitted. So I hope you understood now. Any problem?
No, sir.
Okay. Please try to hit this problem. And remember, it is a concept of that one conduction. When two identical charge particles are touched, so total charge will be divided into two parts, okay, equally two parts. Because they are identical, so capacitance will be same. If they are not identical, then what will be? It will be discussed in the next chapter, that is capacitance. We will again take 3 minutes. Did you understood the previous problem? Even you can learn it also, final result. So from today onwards, I'm going to I'll start giving you assignments. So you also will definitely keep on doing all these things. Okay, Mitra, you are correct. Yeah, Ankita also correct. Yeah.
सर मेरा वाला
Uh, Aditya आंसर आया नहीं ना बेटा?
हाँ आ गया तो हम लिख दिए तो आपको चैट में
Oh, okay. Yeah. Okay. Correct.
ओके
Well, if two identical spheres having charge 16 and minus 8 are kept at a certain distance apart, then the force is F. So you see, this is 16 microcoulomb and this is minus 8 microcoulomb. So say separation is R, then force is F. So it means it is nothing but K by R 16 into 8, because here we have put only magnitude, okay, you cannot put minus 8. Into 10 to the power minus 12, because it will also be 10 power minus 6 and it will also be 10 power minus 6. So 10 power minus 6 into 10 power minus 6, it's 10 power minus 12. Okay. So this is the first case. Now what will happen if we connect them by metallic wire? So what is the total charge? Total charge is 16 minus 8. It means total charge is 8 microcoulomb. Okay. So total charge is 8 microcoulomb. So now 8 microcoulomb will be divided into two equal parts. So this will be 4 microcoulomb and this will also be 4 microcoulomb. Then what is the force between them? Okay. So say it is F dash. That formula will be what? A by R into 4 into 4 into 10 power minus 6, 10 power minus 6, 10 power minus 12 something. So this is the F dash. So this is equation number 1, this is equation number 2. If I divide 2 by 1, so I get F dash by F. So other parts will get cancelled only. So it will be what? 4 into 4 by 16 into 8 means 1 by 8. So it means F dash is F by 8. So third option is correct. So you please try to hit it.
सर चैट में लिख दिया सर।
Okay, I accept your answer. Mayuk and Aritra. Okay, let us try it. In the question, it is given that if the magnitude of force between B and C is F, so force between B and C is A by R square, Q into Q means Q square. Then we need to find out force between A and B. Force between A and B. Okay, A and B. Force between A and B. A will be K only. And as you know that it is 90 degrees, so as it is R, it is root 2R, so it will also be R only, because generally it will be root 2R. It will be R only. And charge is also same, but the magnitude is same only. So though it is minus Q, you have to put on the Q. So it is nothing but F only, okay? So C, third is the answer. If you are asked to calculate the force between A and C, so then of course that this part will be under root 2R square.
Then sir option 4 would have been correct.
Oh, okay. Last question of this type, then I'll discuss, I'll go to that one. Coulomb's law in vector form.
sir.
Okay, I accept your answer. Okay, I accept my answer also. You two are sharing two different answers. So you both can check it once more because it is sure that someone is wrong. Okay, this one is really wrong. Well, let us try to solve it. Okay. Remember, equilibrium means net force is zero. Point charges plus 4q and plus q are at a distance of r apart. Where should a third charge, capital Q, should be placed so that the whole system is in equilibrium? So remember, this is also positive only, okay? Say it is placed at here, okay? Say, then what will happen? This charge will be repelled by Q and this charge will be repelled by this 4Q also. So it means no question of achieving equilibrium by this charge. Because equilibrium means what? Net force is zero. If one force is in this direction, other force must be in this direction. Then only it can attain equilibrium. So it means it is sure that capital Q cannot be placed in between them. Okay. Now,
Yes, sir.
say I am assuming capital Q is here. Because capital Q is positive. Okay, it is not given. Huh? So now what will happen? You see that capital Q will repel this, and this 4Q will repel this. Okay, so there is a chance that this will be in equilibrium. Well,
Yes, sir. सर मतलब +4Q एंड Q इसका जो नल पॉइंट है उस
but
नल पॉइंट में हम
no,
छोटा
no,
Q
no,
को रख
no,
दिए
no, but नहीं, यहाँ पे एक्चुअली ना हार्ड पॉइंट चार्ज को पॉजिटिव ही है, वो नहीं है। पॉजिटिव होगा ना, इट विल बी इम्पॉसिबल टू गेट एट इक्विलिब्रियम because you see this is an equilibrium now, मान लो, but this is not an equilibrium ना, because they are saying that whole
दोनों
system
धकेल
must
रहा है
be, yeah, because they are saying that the whole system must be in equilibrium.
इक्विलिब्रियम ठीक है तो
So
Q को अंदर ही लाना पड़ेगा
uh, so first of all that Q should be negative, okay, that Q should be negative, but it should be uh, away from this and closer to this.
हम्म
Why this is so? Because you see, this is a large charge, no? So
हम्म
distance can be also more. As it is a smaller charge, so distance can be less. So what you can do here, take it as the x, okay, and it will be automatically r minus x. So for on this, actually net uh, force is zero. Okay, even that way you can take here also net force is zero. Say I am taking net force on it is zero. Okay, force on 4Q is zero. Sum of all the forces on 4Q is zero. So it is nothing but F1 plus F2 only. Okay. What is F1? F1 is the force given by this on this. Okay, sorry. That will be attractive only.
Towards inside.
Actually, that can also be found out, okay, later. I don't know, say, we assume that I don't know, I don't know about the sign of this sign, okay. So this will be automatically calculated also later. You see, how can I? Say F1, so F1 is what? Force between that capital Q and 4Q. So it will be what? K into 4Q into capital Q by X square plus. What will be F2? F2 is the force given by this and this. So it will be what? K 4Q into Q by R square must be equal to 0. So from here we can say K can be neutralized with that 0. Small q also can be neutralized with that 0. Okay. Then
So capital Q is a point charge. So we can replace it by 1.
no. If it is a point charge, then how can you that one say that you
So
can
magnitude तो 1 होगा ना.
you is it unit charge? No. It is point charge but not unit charge.
Okay, sir.
Then 4 can be cancelled. By R square. But here also now two variables are there actually. Capital Q is also variable as well as X is also variable. Na? So I think I have to take the equilibrium of this. Means you can take any one of them, okay. But if you take only this, okay, then you are going to get two variables, okay. As there are two variables, so we need one more equation. So for that one more equation, you need to take the equilibrium of another charge. Say I am taking now the equilibrium of that minus Q, okay. Again, I am repeating for minus Q. F1 minus Q must be 0. Okay. So how many forces are there on minus Q? It will be two forces, okay? F1 and F2. And what is F1? Say it is force given by this. So it will be K 4Q into capital Q by X square. Then what will be the force between this and this? That will be A capital Q small q by R minus X whole square, okay? So from here you can cancel K, you can cancel Q, you can cancel small q also. So from that you can get from this you can get 4 by X. It means 4 by X square. It means 2 by X equal to 1 by R minus X. Okay. So twice R minus twice X equal to X. It means twice R equal to 3X. It means X equal to 2/3 of R. And what is X? X is measured from the that on 4Q. No? In the figure you remember 4Q, and I have taken X from here. No? That is R minus X. So that is 2/3 of R from 4Q. So it means from small q, what will be the distance? It will be R minus 2/3. So it means R by 3. So this part will be R by 3. So R by 3 from Q. That is correct. And 2R by 3 from 4Q. So 2R by 3 from 4Q is not there. Okay. So only 2 is here. Yes, that is correct. Only second one is correct. Understood, beta? Any doubt?
No, sir.
So let us discuss Coulomb's force in vector form. Please write down. Coulomb's force in vector form. Say we have two charges in our in our Cartesian coordinate system. X, Y axis is there. Okay? Say that Q1 and Q2 are 2 point charges. We are going to discuss force expressed by 1 given by 2, as well as force expressed by 2 given by 1. Initially, I am taking both are positive charge. Okay? So if one of them is negative charge, so what will be the differences? So you will understand automatically. So say the position vector for the first charge is R1 and the second charge is R2. Well, as shown in the figure. Then, if we calculate electrostatic force on Q2, because of Q1, as both are positive charge, they will repel each other. So Q2 will get a force away from Q1. Sure. So the force will be what? Force will be, this is read out as force on 2 by 1. F1 means force on 2 by 1 means 2 is experiencing, 1 is giving. This part is Coulomb's constant. F21 equal to, first of all, it is in vacuum, I am assuming, so it will be 1 by 4 pi epsilon only. Here we have to put magnitude only. And here the separation, okay, this is the separation. And from vector, you know, R12 is equal to R2 minus R1. So R12 square. And then for that direction, we have to give a unit vector. No? So R21 like that. Unit vector, okay. And R21 is what? R21 is nothing but R2 minus R1. And R21 unit vector is nothing but R2 minus R1 divided by magnitude of R2 minus R1. That part is understood, I think, from the vector. Here R21 is nothing but R1, R2 minus R1. Similarly, force on Q1 due to Q2. So it will be in this direction. Q2 will repel it. So as it will repel it, so it will be R, the direction will be R1 minus R2. It will be like that. It will be like that. So the force on Q1 due to Q2 can be written as F12 equal to Coulomb's constant is 1 by 4 pi epsilon naught Q1 Q2 by, that is magnitude only, okay. Magnitude is square. So if you write R21, or you can write R12 also, no problem. There is magnitude. But unit vector should be written well, okay. That is very important because you see this is R21. It will be in this direction. And that is R12 in this direction. Complete different, complete. So you cannot make the mistake. Okay? So this is the finally the vector form. Okay. And you understand that this equal to negative of this R12 is always equal to R21. minus of F1. So it means F12 also will be equal to minus of F1. Means force given by this on this is equal and opposite to the force given on this by this. Okay, equal and opposite. If one is pulling, the other is 5 Newton, then other also will be pulled with the first one with the same force on it. Okay. The action is opposite. Well, from the theory we have discussed above, so you can try to solve this problem. Very easy, conceptual. Just you are going to get 2 minutes. The electric force on a charge Q1 due to Q2 is this. Then what is the force on Q2 due to Q1? Yes, Mayuk, you are absolutely correct.
Sir, should I write the answer in chat?
Okay.
Sir,
Yes, yes, you are correct. Yes, yes, all of you are correct. All of you are correct. Well, so it will be equal and opposite. So the answer will be what? Simply minus 4i plus 3jk. Yeah. So let me try to frame a question for you. Find the force on, find the force in vector form on 1 Coulomb charge at 111. So this is position coordinate. From that you can easily calculate the position vector also in meter by and another charge 2 Coulomb at 222 in meter in vacuum. So you please try to hit this problem. I hope question is understood, no?
Yes, sir. Sir,
Okay. Okay, if you want, you can put the value of K 9 into 10 power 9. Otherwise, you can keep it in terms of K only, no problem. That is up to you. Okay, let me also try it. First of all, what I need, force on 1 by 2. Okay, that is I need actually. Force on 1 by 2. So that will be K. Then 1 into 2 only. And R1 is equal to what? I cap plus J cap plus K cap. Okay? And R2 is what? That is 2I cap, 2J cap, 2K cap. So here it is R2 minus R1 only, which is square. Because you see, that this is Q1, this is Q2. Okay, okay. No, no. That is actually what I need. I need force on 1 by 2. Na? So it is R1, R2. So in this direction. So it will be R1 minus R2. Okay. R1 minus R2. So there will be no problem because it is square. But in unit vector, it will create some problem. So that is why. And here it is unit vector. Na? So that is nothing but unit vector is
R1 to
it is
cap.
nothing but R1 minus R2 by magnitude of R1 minus R2. Or simply you can write R F1 to K. Just write Q1, Q2 only. Okay, first. So you can simply write K Q1 Q2 by R1 minus R2 whole cube into R1 minus R2. So that will be your answer, okay? So let us now put the values. So value will be what? That is K1, 2 by R1 minus R2, R1 minus R2, R1 minus R2. It will be what? 1 minus 2 is minus 1. That is also minus 1. That is also minus 1. That is K. That is J. And R1 minus R2 magnitude will be what? It will be root 3. So it means it is root 3 cube. Okay. And it is I plus J plus K with a negative sign. So it means we can finally write the answer as minus 2K by 3 to the power 3 by 2. Because you understand that under root 3 is nothing but to the power half only. So 3 to
Sir,
the
I
power 3 by 2.
overlooked that minus sign.
Pardon?
सर माइनस साइन ओवरलुक करिए थे हम वो वाला
Okay, okay, okay.
बाकी तो सेम आ गया
I
है
plus J plus K. बोलो बेटा ये है आई थिंक दिस इज द फाइनल आंसर ओके एनी प्रॉब्लम
यस सर नो सर
take some time to see the calculations and immediately try to write force on 2 by 1 force on 2 by 1 okay okay correct force on 2 by 1 Ankita are you getting force on 2 by 1 what it will be as you know that it is equal and opposite only na so negative of this so it will be positive only just only sign will be changed nothing else. And one more thing, you please try to understand. If this is minus 1 coulomb, here is given Q1 is 1 coulomb. Na? Say if it is minus 1 coulomb, then what will be the answer? You know, just without calculating, just looking at the board only, okay? It is already there, okay? It is already written everything. So can you write, can you solve this problem? If I give the charge, first charge as negative 1 coulomb and force on 1 by 2 only we need, okay? Then what will be the answer? Please try to enlighten it. Yeah, Muir, correct. Others are same, okay? Only the first charge is negative, not positive. Okay, yes. You see, if it is negative, then of course it will be attracted only. Okay, initially it was repelled, now attracted. Everything will be remaining same. But just negative of this, it means this only. Okay, you have to write F12
The
only, but
direction will change, sir.
only
Just
the direction will change.
magnitude will be same.
Yeah, yeah. This is a question. I think you'll find little bit tough, but still I want to give a hint. Okay, because it involve class 11 concept also. So please try to do it. Okay, and remember, Coulomb force is a conservative force. Okay, and it is a central force. Already we have discussed. So take 3 minutes. It will be the last question for today. Okay. And in the next class, we will discuss electric field. Okay. And I'll give lot of questions. You'll keep on doing. And one more thing, I'll give you a that one practice sheet. It will have question also and solution also. Okay. So, and I am going to take some test from this practice sheet only. Okay. Just to check whether you are doing each and every question from this sheet or not. Okay. So take it very seriously and you please go through the sheets properly. If you don't understand any problem from the sheet, obviously I'll take care of it in the next class. But you have to keep on doing. Okay, I accept your answer. Okay. See, here discharge is fixed, okay? So, and discharge is thrown in this direction, but its movement will be along this only, okay? Like that.
So it will increase the
Because
distance.
it will repel, na? That is why. Okay. Now you see, at any moment, say when the charge is at this position, okay? So the Colombian force will be in this direction only. When the charge is at this position, the Colombian force, repulsion force will be at this direction only. So it means if you sit here, if you are standing here, so force is and the position vector is both are along the same direction only. Force and the position vector both are along the same direction. So it means torque will be zero only because torque equal to what? R cross F. It means R F sine theta because R and the F same direction. So sine 0 is 0. It means torque about that capital Q is 0. So as the torque about capital Q is 0, it means what? Angular momentum will be conserved. So as tau equal to 0, but tau about capital Q day, that is very important. So angular momentum initial must be equal to angular momentum final. And you know that angular momentum is equal to R cross mv. Angular momentum equal to R cross mv. Yeah, R mv sine theta. Okay. But remember here theta is the angle between R and mv, which is not 30 degree, okay, at this position. Because R direction is this way, mv is this way, so it will be 150. Or you can do one thing, you know, this is R, na? This is R. So you can take mv sine 30. Because mv sine 30 will be perpendicular only. No? You can directly take that one also. So angular momentum initial is what? R mv sine 30. Means perpendicular component of mv. Because parallel component will create no angular momentum. Na? Because R and mv will be anti-parallel to sine 180 is 0 only. So only the perpendicular component will create angular momentum. So this is the initial angular momentum. Momentum is what? You see, very important. When it is at the shortest separation, minimum separation. Remember, when it is at the minimum separation, so this line should be perpendicular. Because you see, if it is not perpendicular, it means what? Either the point is coming towards or it is going away. But it is saying that it is shortest, okay, minimum. So that length should be perpendicular only. So it means at this position, if the velocity is v, so it will be what? Shortest distance r m v dash sine 90 degree. Okay, sine 90 degree is one only. Now v dash is already given. It is 1 by root 3 times of this. Okay, got cancel. R v half sine 30 is half. Small r v dash is what? V by root 3. V got cancelled. Even that V by root 3 also we can calculate, conserving the energy, you know. here the potential energy and kinetic energy, and here the potential and kinetic both will be same only, because electrostatic force is conservative force. Energy neither be created nor be destroyed here. So from this we can understand that it will be √3/2. So answer is A. Understood, guys?
सर एक बार फिर से समझा दीजिएगा.
See, first point, here it is the charge, okay, and here it is the charge. ये charge fixed है.
हाँ सर.
When you throw in this direction, okay, because of the repulsion, इस trajectory कुछ इस तरह का होगा. किसी भी मोमेंट पे तुम देख लो, यहाँ पे अगर तुम बैठ जाओ तो कोलम्बियन फोर्स जो है ना, तुम्हारा पोजीशन वेक्टर का साथ ही लाया करता है. जैसे चार्ज जब यहाँ पे होगा तो पोजीशन वेक्टर इसका ऐसा, फोर्स भी ऐसा, तो मतलब उनका बीच में एंगल क्या होगा, 0 डिग्री. तो टॉर्क हो जाएगा 0, बिकॉज टॉर्क इक्वल टू R×F, RF साइन 0 0. जब टॉर्क 0 होता है ना, तो जिस पॉइंट के बाद टॉर्क 0, उसी पॉइंट के बाद एंगुलर मोमेंटम हमेशा कंजर्व होता है. तो हम लिख सकते हैं एंगुलर मोमेंटम इनिशियल इक्वल टू एंगुलर मोमेंटम फाइनल. एंगुलर मोमेंटम का फॉर्मूला होता है बेटा RMV, मतलब R और MV का वो कंपोनेंट जो R का परपेंडिकुलर है. तो बिगिनिंग में R इतना है, बिगिनिंग में R इतना है, और MV इतना है, बट MV हमें नहीं चाहिए. MV का ये वाला कंपोनेंट चाहिए जो कि MV साइन थीटा होगा. और फाइनली कहाँ है, जब ये शॉर्टेस्ट में होता है. शॉर्टेस्ट में होता है तो ये हमेशा 90 डिग्री होगा, नहीं तो शॉर्टेज नहीं हो पाएगा ना. अगर ए लाइन ऐसा है, अगर ये लाइन ऐसा है, तो आप मुझे बताइए शॉर्टेज थोड़ी हुआ, इसका बाद तो और शॉर्टेज होना बाकी है ना. शॉर्टेज में हमेशा डिस्टेंस परपेंडिकुलर ही होगा वेलोसिटी का. तो इसीलिए वहां पे वो,
सर्कल में रेडियस का होता है.
हाँ हाँ हाँ, इसी टाइप का. इसीलिए वहां पे हो गया है R डैश या स्मॉल r M V डैश को बोला गया था V/√3. यहाँ पे साइन 90 आएगा जो कि 1 है. ओके ओके, सी यू इन द नेक्स्ट क्लास.